In this episode, we talk about lines of latitude and longitude, page 75 from our Social Studies workbook. Lines of latitude and longitude are imaginary lines. They are found on globes and maps, but they do not really exist on the Earth. These lines help to identify and determine the position of places on Earth. Characteristics of lines of latitude. Lines of latitude are the lines running across the globe or a map from east to west. These lines are drawn in circles and are parallel to the equator. These circles get smaller and smaller as they approach the poles. They are numbered in degrees from 0 degrees to 90 degrees. The North and South Pole are just points. The North Pole is 90 degrees north and the South Pole is 90 degrees south. Lines of latitude are determined by its position north or south of the equator. The equator is 0 degrees, and it is the longest line of latitude and the most important line. The equator is the only line of latitude which is a great circle. The equator divides the Earth in two halves or hemispheres, the northern hemisphere and the southern hemisphere. Other important lines of latitude are the Tropic of Cancer, 23.5 degrees north of the equator, the Tropic of Capricorn, 23.5 degrees south of the equator, the Arctic Circle, 66.5 degrees north of the equator, and the Antarctic Circle, which is 66.5 degrees south of the equator. Here we have a diagram showing lines of latitude. So we have the equator. Everything above the equator is considered north latitude. Everything below the equator is considered south latitude. We have the North Pole to the top and the South Pole to the bottom. The diagram to the right of that shows equator, and then we have the Tropic of Cancer, 23.5 degrees north, the Arctic Circle, 66.5 degrees north, and whatever happens above the equator also happens below the equator. So we have at 23.5 degrees south the Tropic of Capricorn, and then at 66.5 degrees south we have the Antarctic Circle. We turn to page 76. Characteristics of lines of longitude. Lines of longitude are the lines of meridian running from north to south, passing through the poles. They are also called midday lines. Lines of longitude are numbered in degrees from east or west of prime meridian or Greenwich meridian. There are 360 degrees of longitude. They go as far as 180 degrees west and 180 degrees east. The most important line of longitude is the prime meridian. Each line of longitude forms a semicircle. Together with the lines on the opposite side, they form a circle. Each line of longitude is a great circle. Lines of longitude running east of prime meridian, which is 0 degrees, are called east longitude, and those running west are called west longitude. Every place on Earth's surface has a longitude so many degrees east or west of prime meridian. Note this carefully now. Lines of longitude are not parallel and are furthest apart as they cross the equator. Now, parallel means that they are the same distance apart and that they will never touch. Lines of latitude are parallel to each other. They are the same distance and they never touch. However, lines of longitude, they are not. They are going to touch at the poles, and they are widest at the equator and closest as they go towards the poles. All right, so the distance, they are not equidistant from each other at all points. Let's look at the diagram showing lines of longitude. So here we have the prime meridian, and it divides the earth into the east and the west, and we have anything to the right of prime meridian is considered east longitude, and anything to the left of prime meridian is considered west longitude. Now you have an exercise here that says use a map of the world to locate the following places: Port of Spain, Trinidad, and we always say LA before we say LO, so you need to give the latitude then the longitude. Mexico City, Cape Town, Tokyo, Kingston, and Canberra, Australia. We go now from page 76 to page 77. Name the countries which can be found at or near where these lines of latitude and longitude cross, and you will do that. The next topic says that we should use lines of longitude to calculate time. Remember that lines of longitude are midday lines or meridians, so we can use them to calculate time. Time is calculated from 0 degrees longitude or Greenwich Mean Time, GMT, or Standard Time. The Earth rotates in an easterly direction towards the Sun. As the Earth rotates from west to east, all places to the east of the same meridian receive the Sun first during day. Therefore, places to the east are ahead of time than places to the west. The world is divided into 24 time zones, one for each hour of the day. Time zones are centered on the prime meridian running through Greenwich near London, England. Time can be a number of hours ahead or behind Greenwich Meridian or GMT. For places east of Greenwich Meridian, an hour is added for each time zone. So time east, we are going to add. For places west of Greenwich Meridian, an hour is subtracted for each time zone. Time west, we subtract. Note carefully. All places within the same time zone have the same time. Time is only changed when one crosses into another time zone. So let's calculate time. The Earth rotates 360 degrees of longitude in 24 hours and 15 degrees in 1 hour. How did we get this? That would be 360 degrees total rotation divided by 24, and that gives us 15 degrees. So 15 degrees per hour. Now, the Earth rotates through 1 degree of latitude in 4 minutes. How did we get that? 60 minutes, that makes the hour, and 15 degrees in an hour. We'd use that to divide the 60 minutes, and we get 4 minutes per degree. Now, a place 15 degrees west is 1 hour behind GMT or Greenwich Meridian Time. A place 15 degrees east is 1 hour ahead. If it is 12 noon at Greenwich, which is 0 degrees, the time at 15 degrees west will be 11 a.m. and at 15 degrees east, the time will be 1 p.m. Let's look at example 1. If it is noon at Greenwich, that's 0 degrees, what time will it be at a place 75 degrees west? First, we are going to find the difference in longitude. So it will be 75 degrees minus the 0, and that's equal to 75 degrees west, okay? The difference in time is equal to 75 divided by 15, which is equal to 5 hours. So time at Greenwich is 12 noon. Time at 75 degrees west is going to be 12 minus 5 hours, which is 7 a.m. or 5 hours behind GMT. Let's move from page 77 to page 78. At a place 75 degrees east, time is 12 noon plus 5 hours, and that's 5 p.m. 5 hours ahead of GMT. Example 2 now. If it is 5 a.m. at a place 30 degrees east, what time will it be at 90 degrees east? First, find the difference in longitude, and that is 90 degrees minus 30 degrees, leaving us with 60 degrees. That's the difference. Then divide that now by 15, right? And that is 60 divided by 15, giving us 4 hours. So if the time at 30 degrees east is 5, and we're going to go east, further east to 90, time at 90 degrees east is going to be 5 a.m. plus the 4 hours, giving us 9 a.m. So the further east we go, we have to add the respective hours. Example 3. If our place is 45 degrees east of the meridian and the time at the meridian is 12 noon, what time will it be at the place 46 degrees east? So the difference in longitude is 46 degrees. The difference in longitude is 46 degrees divided by 15, which gives us 3 clear hours plus 1 degree as a remainder. That 1 degree is equal to 4 minutes. Time at Greenwich is 12 noon, and time at 46 degrees east is 12 noon plus the 3 hours and 4 minutes, giving us 3:04 p.m. Example 4. If it is 11 a.m. at a place 75 degrees west, what time will it be at a place 30 degrees east? Now, this one is special because we are going to have to cross the prime meridian. The examples we looked at before were always in the same hemisphere. We're either east or we're west. Now we're going to be moving from one hemisphere crossing the prime meridian into another. So let's look at the difference in longitude. That is going to be 105 degrees. How did we get that? We would say 75 degrees to bring us to prime meridian plus another 30 degrees going east. So that's 75 plus 30, giving us what? 105 degrees. So just remember this. Any time calculation that requires you to go over prime meridian from the western hemisphere to the eastern hemisphere, you must add the degrees. All right, so 105 divided by 15 will give us 7 hours. So time at 30 degrees east is equal to 11 a.m. plus 7 hours, equaling 6 p.m. So you have an exercise here, and you can do those and turn them in later. Let's move from page 78 now to page 79. The international dateline is an imaginary line drawn north and south through the Pacific Ocean along 180 degrees east or west of Greenwich. At this line, each calendar day begins at midnight. That is a difference of 24 hours. A traveler gains a day when moving in an eastward direction. If he is traveling from west to east and crosses the international dateline at 180 degrees, a day is gained. On the other hand, a traveler loses a day when traveling in a westward direction. So here we have the map showing the international date line. And unlike the prime meridian, it does not run in a straight line. And they have done this so that sections of Siberia and other little islands in the Pacific will all be able to share the same time zone. In this unit, we looked at lines of latitude and longitude. We looked at the characteristics of lines of latitude in that they run from east to west, but they actually measure north and south of the equator. The equator is the most important line of latitude. Lines of latitude are also parallel, meaning that they run in the same direction, they never touch, and they are the same distance apart. Some of the important lines of latitude are the Tropic of Cancer, the Tropic of Capricorn, the Arctic Circle, and the Antarctic Circle. We also looked at characteristics of lines of longitude. Lines of longitude are also called midday lines. Each line of longitude is a great circle, unlike the lines of latitude where the equator is the only great circle. All lines of longitude are great circles. We also discussed using lines of longitude to calculate time. We said that the Earth goes through 360 degrees of rotation in 24 hours, and therefore it goes to 15 degrees in an hour and 1 degree in 4 minutes. When calculating time, please remember to find the difference in longitude and then divide that by 15. And if you're going east, you add, and if you're going west, you subtract. In any case where you must cross Greenwich Meridian, then you're going to add the degrees and then divide that by 15. Okay? And finally, we looked at the international date line. So please review as many times as necessary, and we'll see you in the next episode.